NASA just fired up a powerful new lithium plasma engine, lithium fed magnetoplasmadynamic thruster or MPD, a glowing red plasma engine firing up with a tungsten electrode inside is blazing white hot at over 5000 degrees Fahrenheit, and that's hotter than lava. While it blasts out lithium plasma, and get this thing just hit 120 kilowatts of power. That's more than 25 times the power of the electric thrusters flying on NASA's Psyche spacecraft right now. And that's the most powerful one NASA has ever used in space. Psyche's engine are already pushing that spacecraft toward 124,000 miles per hour in space with gentle but continuous thrust. Imagine what 25 times that power can do when scaled up. MPD thrusters, researched since 1960s but never flown operationally until we are pushing these boundaries now. This lithium fed version is the next level, breaking a decade long dry spell in propulsion tech. And we are talking about 120 kilowatt beast that doesn't use liquid oxygen but liquid metal running on lithium metal vapor. But why lithium? Well, why not? It's the lightest metal. It reduces the spacecraft mass massively. It ionizes easily, produces efficient plasma, and it's more cheaper, more abundant than the costly xenon gas used in many ion thrusters. The perfect combo. It represents a huge leap in high efficiency propulsion technology. But this breakthrough is literally the key to becoming a multiplanetary species. To understand why this is a big deal, we have to look at the rocket equation. To go faster, you need more fuel. But the fuel adds weight, which requires even more fuel to lift. It's a vicious cycle. Conventional ion thrusters like those on the Dawn spacecraft are incredibly efficient, but they have the push of a piece of paper. They take forever to speed up. But this technology, MPD, unlike any traditional chemical rockets, uses electromagnetic field to accelerate lithium ions at incredible speeds, delivering steady, high thrust performance while using far less propellant. Paired with a future nuclear power source, it could dramatically shorten travel time to the Mars, reducing the spacecraft mass and make crewed missions safer. But the next goal is to scale it up to 500 kilowatt to 1 megawatt per thruster for a crewed Mars mission. Picture this: shorter trip times to Mars means less radiation, less bone density loss, less psychological strain. But how does the lithium plasma engine works? I mean, how do you turn a soft metal like lithium into a cosmic engine? Well, it's all about physics 101. Instead of heavy gas like xenon, which is super expensive, NASA is using lithium. It's lightweight, easy to store, and turns into vapor at high temperatures. This lithium vapor is injected into a chamber where it hits a massive electric arc. This strips electrons off the atoms, creating a superheated plasma. Here's all the magic. By using a massive electromagnetic field, the engine accelerates that plasma out of a nozzle at mind-boggling speeds. Because the exhaust velocity is so much higher than a chemical flame, you get way more power. As mentioned earlier, this specific prototype hit 120 kilowatts. To put that into perspective, the electric thruster currently used on satellites usually have around 1 to 5 kilowatts. So we are talking about a massive leap in power density. So the NASA recent test isn't just a lab fluke, it's a part of a strategic shift towards Mars. According to NASA's tech demonstration, using lithium-fed plasma engines could drastically shorten the transit time to the red planet. And the speed? Well, it does matter, because the faster you get to the Mars, the less time astronauts spend being bombarded by the cosmic rays radiations. But there is one more. In fact, the biggest benefit. Because the engine is so light and so efficient, you don't need a ship that is 90% fuel tank. you can carry more science gear, more food, more people. But there's a catch. To run a 120 kilowatt engine or a cluster of them for a massive ship, solar panels won't cut it once you get further away from the sun. This technology is being designed to pair with space nuclear power. NASA is already working on the Kilo Power project, small nuclear reactors that could provide the power for these lithium engines 24/7, bringing us one step closer, one more step to next giant leap in deep space exploration, and Mars is getting closer, much closer. What do you think? Will we see humans on Mars with this tech by 2035 or 2040? Drop your thoughts in comments and don't forget to hit the like and subscribe button, and I will see you in the next one.